Show that 3.142678 is a rational number. In other words, express the same number in the form p by q, which is a way to represent a rational number where p and q are integers and q is not equal to 0. We know that we represent a rational number in the form of p by q using this form, where p and q can be integers but q cannot be equal to 0. Now this number is 3.142678. Of course, this number is not in this form, and you have to show that this is a rational number, therefore this number should be written in this form, can be written in this form. Well, here is a trick, and we have learned these things in our previous grades. This is decimal point. Now, how many digits do we have after this decimal point? 1, 2, 3, 4, 5 and 6. So if we multiply this number by 1 and then 1, 2, 3, 4, 5 and 6, that is 10 raised to the power of 6, right? Then this decimal from here, it will come to this position. This will be the new position here, and this number will become 3, 1, 4, 2, 6, 7, 8. Then this is 0.0. 0.0 means simply this. Okay, but since we have multiplied this number by 10 raised to the power of 6, we'll have to divide the same number with 1, 2, 3, 4, 5 and 6. That is with 10 raised to the power of 6. We have to divide by this number also. Why? Because when you are dividing this the numerator and the denominator with the same number, this becomes actually what? 1. So 1 multiplied by this number is going to be the same number, so number will not change. But what it will help is, now by this 10 raised to the power of 6, your decimal number, this decimal point will come after 8, and this is this number, and here you have 10 raised to the power of 6, so this is 1, 2, 3, 4, 5 and 6. So this is now of the form p by q, where p is 3142678 and q is 100000. Okay, now if you don't want to do all these things, simply do one thing, that count the number of digits that come after the decimal point. In this case it was 6, so write 3, 1, 4, 2, 6, 7, 8 and simply divide this by, write 1 and then 1, 2, 3, 4, 5, 6. That is the number of digits that come after this decimal point. This is in the form of the form p by q. Show that point 3333333, it's never going to end, that is equal to 0.3, and we have put a bar on 3. That shows that it will keep on repeating. Can be expressed in the form p by q, where p and q are integers and q cannot be equal to 0. Same question, you have to express this number in the form p by q. Now this is 0.3333 and so on. That is, it is 0.3 this much. Okay, if we multiply this number by, let's say that this is actually x. This is x is equal to 0.3333, right? So if we multiply this number by 10, 10 multiplied by this, and same thing here, 10 multiplied by this becomes 10x is equal to, now you are multiplying this number by 10, this will become 3.3333 and so on, right? Now this is 10x, this can be written as 3 plus 0.333 and it's never going to end, right? So this is basically, when you'll add, you'll get this number. This can be written in this form. Now actually this 0.333333 is actually what we have taken it as x. We assume that let x is equal to 0.3333, right? We have assumed this thing. So this is what actually x. So this is 10x is equal to 3 plus x. So from here you get 10x minus x is equal to 3, and you get 9x is equal to 3, and you get x is equal to 3 by 9, and this gives you x is equal to 1 by 3. Okay, so this is of the form p by q, where you can see that this is p, that is 1, and q is 3. Now this is x is what? 0.3333 is equal to 1 by 3. That is p by q form. Can you see that? Simple. So this is a rational number. Show that 1.27272727 and so on can be expressed in the form p by q, where p and q are integers and q is not equal to 0. Again, same question, you have to show that this number can be written in this form p by q. So this number is 1.272727 and so on. Now if we assume that this is actually equal to x, let's say that this number is x. So this number is x. Now if you multiply this number by 100, that is x multiplied by 100, and the same number 100 multiplied by 1.272727, so this becomes 100x is equal to, this is 127 point, right? Since we are multiplying by 2 zeros, so this decimal point will come after this. So this is 127.2727 and this. Now this can be written as 100x is equal to 126 plus 1.272727, right? Why? 126 plus 1.272727 and so on. This is actually what? 127.272727. If you add, you'll get the same number. This is 100x is equal to 126, and if you notice, actually this is what? This is, we have assumed it to be x, we have seen here. So this is 126 plus x. So from here you get 99x is equal to 126, and from here you get x is equal to 126 by 99, and if you divide by, if you want to further simplify it, you can divide it by 11, right? So if we divide it 126 by 11, we get 126 11 1. No, this is not divisible by 11. This should be divisible by, I think, 9. This should go by 9. If you divide by 9, 9 1 9 3 6 and 9 4 36. Okay, yeah. So if you divide both the numerator and denominator by 9, you get 14, and this is 11. This is 11. So x is equal to 14 by 11. It means that x is what? 1.272727 and so on. This is equal to 14 by 11. It means that this is of the form p by q, where p is 14 and q is 11. So this can be written in the form p by q, and therefore this is a rational number. Show that 0.2353535 and so on can be expressed in the form p by q, where p and q are integers and x and q cannot be equal to 0. Similar question. So this is, let's assume that x is equal to 0.2353535, right? Okay. Let's multiply both the LHS and the RHS by 100. So this is 100 multiplied by x is equal to 100 multiplied by 0.2353535. Now this is 100x is equal to, this is 23.5 5 3 5 3 5 3 and so on. Okay, this can be rewritten as 100x is equal to 23 point, this can be 3 plus 0.2353535 and so on. How? This is 23.3, and if you add 0. This is actually what? This is 0.235, and bar will be on 35 because 35 35 35. So if you write it here, then you'll get 23.535 bar, that is equal to this number, the same number you are getting here, right? 535, same number. So this is actually what? 100 x is equal to 23.3, and this is actually what? This is, we have assumed this number to be what? X. Can you see here? 0.2353535 is actually what? This is actually x. So plus x. So from here you get 99x is equal to 23.3. This 23.3 can be written as 99x is equal to 233 divided by 10, and this can be written as x is equal to 233 divided by 990. X is what? 0.2353535 and so on. This is equal to 233,990. So basically this number, we have represented it in the form of P by Q, where P is 233, Q is 990.